In this lesson, I'm going to demonstrate some of the advanced graphics, and what we'll do is we'll create random designs. So you can create random boxes or any other design that you like in Python. So the basic idea is simple. We'll choose a random heading, and that'll be in the range of, let's say, 0 to 360 degrees, step in that direction. And then we'll choose another random heading and step again. So this is the basic idea, and we'll do this maybe 1,000 or 2,000 times. And I'll also demonstrate as a bonus here, we go through all the colors of the rainbow or something similar. We'll choose and pick any of the colors from the color palette or the RGB colors and so on. But basically the main color modules in computer graphics are primarily used are the RGB, the red, green, blue, and the HSV. And the Turtle and many other graphics libraries accept RGB, but not HSV. So we got to be careful in using these color modules. So what is this random walk? Basically, it's nothing but a mathematical formalization of a path that consists of succession of random steps. So for example, you trace a path by a molecule as it travels in a liquid or a gas, right? The search path of a foraging animal, for instance, would be another example. The price of a fluctuating stock and the financial status would be other examples. And these types of random walks are essentially associated to be with Markov chains or Markov processes. So let me go ahead next and in fact demonstrate this for you. So here we have our Python editor open. We're using Sublime Text. And let me go ahead and just put a comment here. This is going to be a random walk. Great. Let me go ahead and save this quickly before we begin our code. So I'm going to call it random walk 1.py. And let's go ahead with our code. So I'm going to go ahead and do from turtle import asterisk, and then we are also going to use the random module. So we're going to use from random import rand int, and then also our color, right? Because we're going to be using the color as well. So from color sys import HSV to RGB. Next we define the step or number of steps basically, which is 30. I'm just going to put a comment here. So these are simply the length of each step. Next we do the end steps equals, let's say 1,000 or maybe even more. How about 2,000? And then we do the HINC, and this is simply the increment or the hue increment, right? The color increment, or in essence the actual shade. So we're gonna specify this to be equal to, let's say 1.0, and then divided by the end steps. And we can change those later as we run the program, or after we run the program. We can always go back and change this. Specify the width of 2, and again this is the width of the line. All right, next we do the W and the H, and we're going to make this equal to the screen size, which is essentially setting the boundaries of our random walk, right? So this is setting the boundaries of walk. Great. Next we set the speed, and this could be, let's say, fastest, and our color mode goes next, and this will be 1.0, and we're choosing this instead of 0 to 255, right? So we're just saying color mode is 1.0. And next our background color, so BG color of our canvas, we're gonna say, let's say black. We can always change this later as well, and set our hue to be equals to 0.0. And next we do our for loop. So for I in range and steps, What's it going to do is going to set the heading to the rand int from 0, and then let's say 359. Next, it's going to set the color, which is our HSV underscore 2 underscore RGB, and this is going to be hue comma 1.0, and then 1.0 again, and again this is our pen color in RGB. That's what we're doing here, right? So I'm going to put a comment here. So pen color in red, green, and blue. So it's RGB colors. Next we do the hue plus equals the HINC, and what this does is simply changes the color, right? So every time it draws something randomly, it's going to change the color. So let me put a commentary, in fact. So change color, and then once the color is changed, it's going to move forward, right? So we need to tell Python that it's going to take the next step, and then our XY coordinates equals POS is the position. The next, let's do a condition. So if ABS is X, essentially is greater than W, or ABS Y is greater than height, go backwards. So backward step. So basically if at the boundary, step back, right? So once it touches any side of the canvas, for instance, it's going to go backward and step. And let's go ahead and let's be done with this. Great. So we have our code here, simple code, but yet very powerful. So when I run it, you'll notice a canvas would appear and Python is going to start the random walk in color. So let me go ahead and save this and do the run. And Python builds it for a couple of seconds, and there we go. So the Python turtle graphics screen shows up and a random walk begins. And notice these are just colors, right, that we can see change as steps are progressed. So from one step to the other, Python is going to change the colors, and it's going to continue to do so and keep changing its colors and so on. So for example, if I were to, let's say, change the background color from black to white, it's going to change the background color from black to white. Similarly, if I need to increase the width from 2 to, let's say, 4 or any other width of the line, I could do so as well. So let me quickly, in fact, show you. So instead of black, I'm going to go ahead and just do white and run it again. And this time it's going to start with the white background. So depending upon your own requirement, you can set this random walk up. And we can change other settings as well. Okay, so depending upon your own need. So I'm going to make sure that it runs here. Let me fast forward here so you can actually see what Python does. So if I were to bring up the other screen, notice here Python with my background color as black has already filled up the screen and essentially took 2,000 steps while it's still in progress on the background, which is white in color. So this way you can create this program. Let me minimize this. So I hope this helps. Practice, and let's move to the next lesson.